Your Holiness, thank you for joining us this afternoon. We are due to continue our investigation of physics this afternoon with a session that's called Quantum Physics and Its Implications. We will have talks from three speakers, Arthur and Michelle once again, and our good friend Thupten Jinpa will be our third speaker. And Arthur will start our deliberations, I think, by saying something about another fundamental theory in physics, this time relativity theory.
Your Holiness, the challenge of modern science is to think much more carefully and subtly about the world that we inhabit. And while there are many details, yes, carefully and subtly about the world, and while there are many, many details within physics, quantum physics, relativity, that are complicated, hard to understand, I think one of the foundational or most powerful concepts is that of context or relationship. This you see in every field that we take up, even in the simple illusion. Remember the big monster and the small monster? They were the same physical size, but they were in a different context. The lines were different, and so we saw the one monster as small and the other monster as big because of the context or relationship they were in. In Michel's examples also, he was at pains to say the moon was in a relationship to him as he went on his bicycle. And especially in quantum mechanics, this becomes very much the case. We cannot simply objectify the world. That's quite all right. Old friends need to greet each other. Again and again in modern physics, the danger is that we try, as we can in classical physics, to objectify the world. That is to say, to see the world as objects that are separate from and without any relationship to me. So the world is a world populated of objects in the world with no relationships. We see again and again that this does not work in the new physics, that it's a world filled with relationship, and we must remember ourselves and the role we play in constituting reality. Everything that appears in relationship, in a context. And so I'm going to work with you in this new area of relativity theory. But before I do, I can't help but remember how you played with watches. You love watches and machines where you take them apart and you think all of the different parts and how they move, and then you put it back together again, and sometimes it even continues to work. Yeah? That you understand.
Oh, yes, I think very properly.
Sometimes it continues to work.
Sometimes wasn't.
Sometimes you didn't fix the watch. But I know that same feeling. I too loved to take things apart when I was a child and put it together again. The watch is in some ways, or the clock, is an archetype of the old classical physics. The way of thinking for a watch works for all of the world of the macroscopic, of the large things in our world. It's a very powerful way of thinking. But I believe that what we have in quantum mechanics, and especially in the new machines that are being built on the basis of quantum mechanics, is something which is not like the old clocks. It's like a whole new concept, a whole new set of concepts, a way of thinking into these new machines is required. And this is why it's so difficult. I think when we come back in our next incarnation, we will have to think these new machines, and the old machines will be like toys in the antique shop. So we now have in front of us this bold new challenge. The two sides of that challenge are provided by quantum mechanics and relativity theory. So I'd like to speak a little bit about the theory of relativity, what it says to us about the nature of reality, and especially, again, the importance of context and relationship. You know, Einstein loved a world, he sought for a world that was really existing. As Michel said, Michel felt, and I do feel also here, he was not correct in his longing for an old-style world. He was a person right at the crossroads of this new reality, this new way of doing physics. He says, behind the tireless efforts of the investigator, there lurks a stronger, more mysterious drive. It is existence and reality that one wishes to comprehend. And we all have that in our hearts. We wish to comprehend reality. But what is our expectation of how that reality will show up, you know? Now, I'm going to begin with a question concerning this idea of intrinsic properties that Michel introduced. I'm going to look at the same from the standpoint of relativity theory. You know, when you arrive in America, I don't know about you, but most foreigners, when they arrive in America, you have to give your fingerprints, they have to take a picture. They don't yet take DNA, but at some point they probably will take a DNA sample. So what they're looking for are so-called biomarkers that are a unique, enduring set of properties that identify you or me, that identify the object. So we know this object from that object. In the case of the biomarkers, they may look at height or weight, but these can change. You know, you and I can lose some weight, and then it's no longer the right measure. Eye color, gender, they're not unique. There are many people with brown eyes. But fingerprints and DNA, well, that's more or less unique. You could say this identifies the difference between each of us. So in looking for these unique set of intrinsic markers, we think we can identify an object. What are these markers in general? What are the fundamental intrinsic properties of bodies? Galileo, again, because he's one of my favorite philosophers and scientists, he made a distinction which nowadays we call the distinction between primary and secondary qualities. I'll explain more in detail what these are in a moment. So Galileo wrote hundreds of years ago that I think that tastes, odors, colors, and so on are no more than mere names, and they reside only in consciousness. Hence, if the living creature were removed, all these qualities would be wiped away and annihilated. Let's take a look at what these primary and secondary qualities are like. For example, color. Oh, you can't really see much. Maybe you can read it over there on this screen, to the right.
Just for clarification, His Holiness was asking, you're actually talking about the reality of the secondary property themselves, not the whole framework of distinguishing between things and their properties. Because the separation of things and properties is a mental construct. This is in the Buddhist epistemological text that His Holiness was talking about.
Okay, this is, I think, a very important point. Yeah.
No.
거래받는 지금 미다고 해서 집이
나름.
거래 조선에 예요.
나름.
다 릭직디 르
나름.
I think he should be broadcasting on his radio, yes, so that the Tibetans can hear.
저서 제시 제주를 전에 제주 릭직디 거래 제시 조선에 거래가는 예대비죠.
나름.
다지는 다 디지 가서 우리 차바로 봐 지라도 때는 법이 전에 애 지금 가서 원래 철수기 전에 제주 먼 곳이 시작하지. 그래서 제대 배지 타냐라 사람 마도야 그게 가
나름. 주진이 배차센.
어.
주진이 배차, 룹자이 배차센.
근데 제대 총수로 있다고 다 뜻을 되죠. 시험을 편히 왔다.
나름.
상당히 지중 시합이나.
나름. So, for example, a distinction is made in the Buddhist epistemological texts, such as Dharmakirtis. We can attribute a lot of properties on a single thing. And some of these properties may exist by default in the thing itself. So, for example, a conditioned thing could be the fact that it is a product, the fact that it is impermanent, the fact that it is changeable. These are all natural properties of that thing. But we can then attribute many properties, from the point of view of our function. So, for example, 라 최대 최전 남샤다 룹저 두버 군샤 담배도는 주베지 개번 남기 체미 다들은
지금 최대 주제스를 비자리 해지고 지금 파트를 도서 다시.
So many of the attributes that we use in our everyday language are really constructs, and there's a beautiful verse in Dharmakirti's text where he says that the distinctions between things and their properties, the thesis and the evident proof, all of these distinctions, categories, are really categories that are skillfully created by the logicians, by the learned mind.
But they have no reality.
제주 직내에 거래가는 예대비죠.
But there are, of course, other properties which are there by virtue of the existence of that thing.
Okay, so if I paraphrase, as I understand it, you have a thing and its attributes, and as you take away the attributes, you could ask, is there such a thing without any attributes, an attribute bearer that carries attributes but has none? Is there anything left? And you're saying that there are certain attributes, changeability and impermanence and
Yes.
so forth, which adhere to the attribute bearer,
Yes.
that which carries attributes.
Exactly.
And you're able to take away certain of these attributes, which are conceptual designations.
Exactly.
And there's something quite similar, actually, is part of the Galileo quote that I just indicated, because he says things like the color of the rainbow,
배지르죠.
the smell that we have of a cooked meal, the taste, the sound that you're hearing right now, even, these are all conceptually designated. These are all secondary. So he's looking in his own way for a fundamental set.
ben 던줄이야 타냐매봐. 거기서 지금 그 타냐매봐. 거기서 테스트 사운드 싱그러.
Yeah, but these secondary qualities, even the animals must be able to perceive them.
Yes,
So
animals have them.
but they don't have concepts, they don't have categories.
Good
다
point.
주저들이 size, shape, 다 마스
These are the primary ones.
사이즈다 타임 사이즈 배지 미드에는 뭐도 배지라고 하고 그러죠.
The time also, it might be relative.
Time also might be relative. Yes.
Size, shape,
Size.
number. These are, I think, human mind that's service research.
또 쿠주시단 제면은 디자외 계절 파샤거래.
사이즈 파샤를
나래.
primary qualities,
순항어디
secondary
양아지
qualities.
계절.
Yeah, but you're asking the right question, as I understand it. Are some of these what we call primary? Let's take length, size.
어.
Is it really primary? Or is it also one of the secondary? You know, what about shape or mass or even number? Are they really primary, or are they also part of the secondary? Are there any truly fundamental primary attributes? And if so, what might they be? And what we're going to do is not ask this as a philosopher, but ask this as a physicist.
말하지는 타냐 미싱의 심정문에 가르치듯이 그 부기 뭐들이
네.
다 미셰베 다 지금 타냐 mongu 잔소리도 이제 secondary.
So His Holiness would, pursue the following approach, which is to try to see which, how much of the properties, attributes can be perceived by, animals, the mammals that we share, and then these would be identified as primary, and how much of attributes require the human kind of mind and conceptual kind of, framework.
see.
We'll categorize them as secondary.
Well, here's then an alternate way of approaching this question. What we can do is we can say, all right,
Classical.
classical physics seeks to explain secondary properties, qualities such as color, in terms of primary qualities, such as size and shape and so on. All right, so we take the things which we experience in this hall, for example, all of the experience that we are having right now, listening to my voice, being in this beautiful hall, these are all secondary. From Galileo's standpoint, behind these secondary experiences, there are primary material objects, the light, waves, and so forth, that produce the sound, the light, the color, the experience. And he wants to explain the secondary in terms of the primary. And what we want to do is examine this critically.
D star size, the D shape is low in
말해, 니니가 캐주를. 그저 가도다, 저 정말 입다 정말 캐주 콘도 뜻이 아마도. 유지킹은 다 대 가도다. 대 입sla고 그러봐. 순항무대 캐주래, 반항무대 캐주래. 다 캐주 자와다 야라스.
맞아. 디디 제요나 다다치기냐.
나래, long. So when you connect the two, so the secondary qualities can be seen as arising out of.
Arising from, that's
the
right.
primary.
They are caused by, they are stimulated by. Right? So the sound wave strikes the ear, produces a motion in the ear, that is then electrical signals go to the brain. You can say where, auditory something or other. Ocular nucleus, okay. And then somehow, this is the hard problem, we hear my voice and your voice. But we don't understand completely, but Christoph and others will try to explain that to us later. But the mystery is, from the standpoint of quantum physics and relativity, are these primary qualities, any of them truly primary? And so I want to ask that question and ask it in the context of not philosophy so much as physics. Yeah? So is there a world of intrinsic objects and properties, or is the world, you might say, intrinsically subjective, that the only world we know is the world of experience? And that if it's the world of experience, then it always has this subjective character. It doesn't mean it's not true, it doesn't mean it's false or something, but it always, I'm seeing red, I'm hearing sound, I hear it. Now I can have ideas about it being arising from, but is there ever a way in which I get past the experience to something other than experience? Let's take a look at this from the standpoint of not quantum mechanics, which works with the very small objects of the world, but with relativity theory, which is a revolution in our understandings of space and time and simultaneity and some of the most foundational and fundamental ideas of all of science. They unfortunately only become significant, these effects only become significant at very large speeds, very high velocity. When you went to CERN, you saw how big it was. Part of the reason it's so big and it has the shape it has is because of these relativistic effects, that they have to engineer that machine using relativistic engineering equations. If you engineer it the way you would engineer a classical watch, it would fail. Well, here's my little, I'll do one thought experiment.
And the relativity theory, 다 지게 라제죠 봐. 슈겐테야 돼. 디 지다 지그 녀락배 토래야 카고요레스. 대자 고직 체 첨부지가 돈에 제고 요인자 단다 CERN 이단다 스위스랜드 요베 단다 atom collider 되게 첨부 시부지담 아니 바이 망부 시부지가 돈 교고에 소고에 돼그 체시 첨부 시부지가 돈에 아니 제바치디고 relativity가 돈에 슈겐 카르테가 요마요 돼 나버 또 도르마도 충세간이야 또 도면도
I'd like to do one thought experiment of the type that Einstein enjoyed, and it's the following. I have here a picture of a barn. I don't know if you have barns in Tibet or not, but if you,
따라 건 직다 따라 소리지랬단 따라가 소리지
okay, it has two doors, one in the front and the other one you can't see is in the back. And there's a pole that's below it, and they have a length. The pole has a length. If you measure it, I'm going to say it's a big pole of 25 meters long, so it's a long pole. The barn is only 20 meters long. And the relativistic challenge, the problem which the professor gives to his student, is to fit the long pole in the small barn so that you can close both doors at the same time, take a picture, and then you can open the back door and let the pole go out. Now, classically, that's just impossible because the pole is too long to fit in the barn. But believe it or not, and engineering proves this to be true in the CERN laboratories and so on, that pole shrinks as it gets going faster and faster relative to the barn. It'll shrink, in fact, so much that if you go at a velocity, it becomes shorter. It becomes shorter. If you go at 70% the speed of light, that's about 130,000 miles per second. That's very fast. 170,000, that's like 5 times around the world in 1 second. So from now to now, you'd have to run 5 times around the planet.
So you've got to open and shut the barn doors quite quickly then.
In order to keep the pole from crashing, you'd have to shut and open the doors quite quickly. Okay, but that doesn't matter. It's a question of principle, right? Can you shut the 2 doors simultaneously? Because that's what it means to be inside, right? Is when the 2 doors are closed together and the pole may be moving, and then you quickly open the back door so it can get through, right? So maybe you have a situation where the back door is closed, the front door is open, the pole comes flying in, you close the front door just for an instant, it's inside the barn, you take the picture, then you open the back door and the pole flashes out, right? Now, this seems like it would be...
thought experiment. But this is a thought experiment, though.
Yes, but the equivalent, you can't do it with barns and poles, but you can do it with small particles or atomic clocks and so forth. You can actually show that this experimentally works.
thought experiment.
All right, so this is meant to be a thought experiment, but then you can do a version of this in the laboratory. And everything you do to determine everything, whether the pole is in the barn, shows the pole to be in the barn very, very briefly, because it's going so fast. Now, this is a strange state of affairs. Because the pole was longer, now it seems to be demonstrated shorter. Now, the second part of this thought experiment, and this is a hard one. If I have a pole like this, and I imagine this is the barn, and it comes through the barn, this will become shorter so that it fits in the barn and the barn doors can close briefly. Then it goes out the back open door. But from the standpoint of relativity, this is the same as moving the barn to the pole, right? So there are 2 ways of moving the pole towards the barn or moving the barn towards the pole. They look the same, right? So the question is, well, maybe the barn is moving and not the pole. Okay? So I'm going to assume that the barn is moving. Right? It's the same whether it goes this way or this way. So now the question is, does the pole get shorter again? Or does the barn, which is in motion, become shorter? Einstein's laws, which he discovered, and through pure thinking, no experiments, just pure logic and thought, say that any object which moves gets foreshortened, is made shorter in the direction of motion. So if it's the pole that's moving, it becomes shorter. If it's the barn that's moving, then the barn will become shorter. The pole remains 25 meters long, and now the barn, which used to be 20 meters, becomes 14 meters long. Will the pole fit in the barn? No, definitely not. There's no way you can close the two doors because the barn is far too small. The pole is 25 meters long, the barn is only 14 meters long. Okay, now, if you have scientists, one of them doing the first thought experiment, but in the real world, and another doing the second thought experiment, they're going to have very different opinions. One is going to say, I saw and I took a picture, and here is the picture, and the barn contains the pole, it's inside. The other is going to say, no, look, my picture shows the poles are outside the barn. And you come together in Drepung and you have a nice conversation with each other, and you get in an argument as to who is got a true state of affairs, who's showing the truth concerning the state of the pole in the barn. And Einstein will say, both of them are true. Because what you're looking for is always in a context, a relationship. And when you ask what is the single true state of affairs, you're presuming that there is an objective view from nowhere. There's no person, but just a situation with its own truth. Not a truth relative to me or truth relative to you, but a single absolute truth. And when we forget that relationship or context, then we come into great difficulties. If we remember the context, then when we come together, we will say, of course, given where you were standing and where the pole was moving, then you will see it this way. Given the fact that I was in a different reference frame and the barn was moving, then I will see it the other way. We will have mutual understanding because we understand the different contexts.
This
is a kind of profound result to me, because Galileo said length is objective, length is a primary quality. It shouldn't depend upon my sense organs, shouldn't depend upon me. I should be able to disappear. But in this case, what we're saying is that the vantage point, the viewpoint, is absolutely important to even something as primary as length, as size. In some sense, every property that you have on that list of primary properties is affected by relativity in this way. You must always make your measurements conscious of the fact that it is in context and in relationship. All of physics, quantum mechanics, we've just begun. There are many ways in which quantum mechanics gives the same lesson. You always have to bring the context and observer into relationship with that which is to be observed. And if you're looking for the absolute foundation, the real size, what's the true size? There is only the size relative to an observer. There is no true absolute size or true absolute weight, mass, and so on. It's always in relationship to a vantage point. So we have two views that are classically inconsistent. From a classical standpoint, they can't be. The view from the barn says the pole is inside. The view from the pole, where the barn is moving, says no, the pole is too long and it's not in size. So which is the true state of affairs? both are true, but with respect to two different observers, two different frames of reference. One with the barn, the others from the pole seeing the barn in motion. And that which we took to be primary is now, can really truly be thought of as any length shorter than its so-called proper length. Yeah, I take this to have really great significance from the standpoint of the kind of considerations we have here, that each subjective account, each person who's giving an account will do so in a way that is completely consistent, where the laws of physics are all working perfectly. And in fact, Einstein showed that this is the only way that the laws of physics can actually be operating in each of the two reference frames with objectivity, with real success. So you're looking now at a situation where you could say simply from the standpoint of physics, we're discovering that we have to keep into account ourselves, you could say, the frame of reference of the observer. And you can ask whether there is any place, any frame, any reference frame, which is the privileged reference frame, and this is the search for the ether. Perhaps the ether provides a reference frame. Now we say there is no ether, so there is no preferred reference frame. Each person has the same claim to truth, even when they look to be opposite. Now there's a quote from David Bohm, your friend David Bohm, who I also knew very well and was also a great physicist, a person of extraordinary brilliance. I wish he were here. He would be a brilliant companion for this work. That in relativity theory, not only are lengths shortened, time actually can slow down and speed up, if you will, according to this motion. The relativity of simultaneity, that is to say, my two fingers are clicked simultaneous, but if you're moving, you'll see one first and then the other, move in the other direction, it'll go in the opposite, so that you take these three, length shortening, time slowing, and relativity of simultaneity, and that becomes the new framework for understanding the new physics. Bohm says, the analysis of the world into constituent objects has been replaced by its analysis in terms of events and processes. This is a to me, very powerful statement. We so much want the world to be made of objects like glasses and bowls and Kleenex boxes and computers. And that then on the microscopic scale, we think also cells and neurons and atoms and molecules, right? But what Bohm is saying is a very powerful statement, that this is a wrong view. Really what one has are events, things which arise, you could say phenomena, and processes, the way in which they evolve in time. And they give the appearance of objects of enduring nature. But what is more primary are the events, the phenomena, and their development. And for that, you always have a position, a subjective, if you will, element.
David Bohm sondan jebe na ngara zo ngema ga tadan de su jing ge chue sa me ngo jebe ga le ya yu dok dok ro jing ge je je object chu du ge yu ro jing ge je je de shi le sha be de de ke ju dan du se je je ba ji go ro bas ta di da dan de gyo dan go du su gyo dan je ne su jing ge chue ge je ba ga le ya ji chu chung wa dang yang da ani chung zu ge ren ba de de ge to ne den ji de wa chung wa so ro ji 땡진 대화를 중요해서 대화만 보기리야 중화라고 지금 강자지 중화만 보지 투병 무슨 제시가 마도 중화한테 실내샤부터는 똑똑지 오브젝트로지 속도 좀 지가 지금 돈에 셔버져야 되게요 말했어.
I want to emphasize that this world is not a world of chaos. In fact, it is the ordered universe, right? People think, oh my gosh, between the quantum physics and the relativity theory, it's just going to be crazy, right? But in order to have a universe which is lawful, where the laws of physics operate, Einstein deduced these are the kinds of things which must be true, and then we check them out in the laboratory and we find, yes, they are true. So this is actually something of great beauty, of great harmony, of great possibility, and yet it's something which ties the reference frame, the place of the observer, with that which is to be investigated, so that the world is constantly arising from the two sides as phenomena. So here are what I think of as some of the implications. I think it's a wrong view, actually, to see and look for a single objective state of affairs. As Bohm says, objects are now being replaced. To think that there's just a single state of affairs that everyone will see in a consistent way is not the case. We have to understand the changes that are associated with context. There's what we might call a fundamental observer dependence. There's always a vantage point. There's always a viewpoint. It may be you asked about the dinosaurs, or back many billions of years ago. No human beings. And yet we describe the dinosaurs. We describe the earth. But we do so as if we were there with this consciousness, these eyes, these ears, and a news team, from Tibet News Company, with cameras that look from a particular vantage point at the situation. Then sure, then there would be a world that would arise, and it would look as they described, right? So you either have a real, you could say, observer, or an imagined observer. Then you've set the context. To take that observer and to forget them is a fallacy. It's simply just a forgetfulness. If we do this, we find, for example, that length is relative, and other attributes which we took to be primary are relative. Now, here's another one, which at least I think must be the case, that what I've just said has to be true at every level. It's not like you get to a certain place and then you break through to objective reality, absolute, right? That you have these same aspects which are based on relationships, these same realities are based on relationships that we experience. Now I have a picture here on the right-hand side. I don't know if you can see it well enough, but what it is, it's a picture of the globe of the earth resting on the back of an elephant. Now this is a story which comes from the ancient Greeks, because when they were trying to understand how the earth was supported, what was supporting the earth, right? So they said the earth must be on the back of an elephant. And then of course they were logical, so they asked, well, what's supporting the elephant? And someone said, well, there's a turtle. See a big turtle.
Greek.
여러 엘리펀트 왜 봐?
So there were no elephants in Europe. So how did they come up with that?
Oh, that's a good question. I think there were known to be elephants. Isn't that right, from Africa? Hannibal. They're not local, but they were known to be present through explorers and war and so
아프리카
on.
먼저 유럽에 다 갖고 그래서.
Yeah. But good question. So the earth rests on the back of the elephant, and then you can ask, well, what does the elephant stand on? And the answer was a turtle. And then the person said, well, what does the turtle stand on? And after that, it was said, well, it's turtles all the way down. In other words, it's just, I don't know, it's the same thing all the way down. More and more turtles.
There is a similar origin myth in the Indian classical Vedic tradition. I think one of the Vedic texts, again, the earth is supported on the back of a turtle.
And then the turtle is supported on the back of another turtle.
So when there are earthquakes, that's when the turtle is moving.
I see. But the reason I bring this is not just because it's a funny story, but because we are always looking for the foundations or the objective reality behind experience. What is it that supports experience? We're looking for something other than experience to support experience. And I think this, on the basis of Einstein's work with relativity and the quantum mechanics, is not a good choice. it's a problem. That actually, when you look ever more deeply, what you find still are context-dependent relationships that give rise to phenomena that may be more and more subtle, more and more delicate, more and more fine, even almost hidden, but with refined instruments or consciousness, one can investigate them at every level. So that what one has is not turtles all the way down, but I would say this context-dependent experience that goes all the way down. And there's no need for any foundation other than that. What that means, though, is that we need to not just be stuck in one vantage point. If you're stuck in the vantage point of the barn, then you see everything from your worldview, everything from your side, then you fight for that truth. So I have a different picture. I have a picture of, let's say, a reality which you circle. You actually learn to take on the position and views of the other. So I should, even if I'm not a Buddhist, maybe Buddhist philosophy is interesting because it brings some thoughts which I hadn't thought before, a way of looking, a way of understanding. Maybe you get interested in physics or neuroscience, something quite different than what it is you were brought in, because it gives a fresh view into reality. And rather than trying to find the foundations of reality in an absolute, one moves around this circle, as I'm going to make a little movement here. So this is the scientist, philosopher, contemplative, making their way around the big questions of our existence. And with this, I'm going to conclude.
소소네다 또 때려서 주셔.
오달날은 간다 직심에
어?
간다 땡을 지체제 되냐 찍어야 돼. 공교가 말했어.
저도 홀리스틱 샤워도 도면도 홀리스틱 샤워.
So, the conclusion is that we need a kind of a comprehensive
Comprehensive,
holistic view.
Yes. Francisco Varela, who you know so well, for him it was the first person, third person, the inner science and the outer science. These are like different views around the circle. Some people now are looking at the second person. How is it we work in dialogue or across cultures with very different, sophisticated, but very different philosophies, to really live into the views of the other, so that we, through imagination and sympathy, we can change the context. We don't have to be born in Tibet in order to study Tibetan Buddhism. We don't have to be born where I was born and my universities to understand these questions. So we can teach each other, we can learn from each other, and by looking then from many vantage points, we come much closer to the, you could say, common understanding or insight that will be of help to us. Yeah. Okay?
Thank you.
Thank you. So, if you're willing, Your Holiness, we will now move to Michel Bitpol
Oh yes.
for our second contribution. So, we'll do an exchange, not, I hope, a superposition.
No. This time. Yes. Here we are. So, my purpose this afternoon is to develop some of the consequences of what I've said this morning. One of the consequences is quite strange and difficult to accept to Western scientists. The problem is that usually when they have a physical theory, they wish to have a view of the world that goes with it. They don't just content with a theory that is efficient, that enable them to predict and to make technology. They want also to have a picture of the world. Einstein was one of these wonderful scientists who dreamt of a grand view of the world. But the problem is that quantum physics has put some obstacles on this way. and that presently there is no view of the world which is both compatible with quantum mechanics and which is uncontroversial, that everybody accepts, every physicist accepts, because each one of the proposed views of the world that fits quantum mechanics has paradoxes, difficulties. Nobody is completely convinced by it. So my proposition is that maybe we have to accept that this physical theory provides us no view of the world. So
가사 노월 가사.
View of the world.
Ah.
View of the world.
Oh.
No.
I
Okay.
think in Sanskrit you would call that
미소스 통수.
in Sanskrit you would call that drishti. Drishti, isn't it?
Tawa.
Now, I want to come back to basics, really to things, elementary things. So, what is science, actually? What is the purpose of science? It could be that science aims at giving us a faithful picture of nature, that it is a mirror of nature. This conception comes in two varieties. The so-called realist varieties, according to which a theory, a scientific theory, is a faithful representation of reality as it is in itself. This is the ultimate dream, in fact, of Western scientists. They want a picture of reality out there, but as it is in itself. The second view is more modest. It says, yes, a scientific theory is a picture of the world, but not a picture of the hidden world. A picture of the manifest world, the world which is visible, empirical world. And so empiricists say that good scientific theory is just a faithful summary of observed phenomena, not more. It's still a picture of the world, but a picture of the apparent world, not more. The second view of science is the other way around. It's not as if we were, so to speak, capturing nature in our nets, but it's us who are superimposing our concepts and our views on our image of nature. Kant was one of the proponents of this idea in Western philosophy, with some nuances, but I think I would skip nuances. The third possibility is what I would call here a middle way. It's, a scientific theory in this way of seeing it is neither a picture of nature, not just a superimposition of our own minds. It's the byproduct of an interaction between us and nature. It's the expression of an interplay between us and nature. And Francisco Varela developed such a view under the name of enaction. It is the theme of his wonderful book, Embodied Mind. According to him, there is no way of putting foundations, of saying that, in fact, we can ground our view of the world somewhere. There is what he borrowed from Buddhist thought, namely dependent arising of the knower and the known. So the interplay is what science gives. For instance, science can give us methods to behave adequately and efficiently in the world, namely to relate with the world in a very clear and efficient and powerful way. Nothing more. And so in that case, a scientific theory is only an instrument for us to orient in the world and use it in a mode which is useful for us. Now, second part of the basics. What is a physical theory? Namely, what is a scientific theory that bears on matter? Well, in fact, in the history of Western thought, there were at least 4 conceptions of what is a physical theory. The first, the oldest conception, was the conception of Aristotle. He said that a physical theory is a statement of the first causes of every phenomenon. The first causes, namely, you cannot go beyond them, according to him. It's quite unlike Buddhism, because in Buddhism you can always find another cause which causes the cause, and so on and so on. But according to Aristotle, there was a first cause, and full stop. And physics should look for this first cause. It was also, physics, according to Aristotle, was also meant to find the essential properties of things, the properties that are most intrinsic.
그런데 이슈 연구로 봐.
라
네.
이슈 연결해.
에스코라스 연구는 이슈 연구로 봐.
So, okay, but after a certain time in which this theory of theories was very much accepted, throughout all the Middle Ages it was accepted, people started to see something artificial in it. For instance, when somebody wanted to explain the virtue of the opium to bring sleep, he said, oh, I can explain that by saying that opium has the essential property of being sleepy, And this sounds quite artificial. Okay, it gives sleep because it is sleepy. Okay, so people like Descartes, René Descartes, the French philosopher, said that this was indeed completely artificial and that you had to explain everything in terms of mechanical interaction, bumps of bodies one into the other, primary qualities, as Arthur told us, namely spatial qualities, extension, velocity, and full stop. Even the qualities, for instance, of the virtue of opium to bring sleep had to be explained in terms of motion of particles. This is what Descartes called a mechanical explanation. Among many other things, Descartes wanted to explain gravitation by way of bumping of particles into each other. For instance, he said that the gravitation was due to the fact that there was a surrounding of subtle matter that bumped into the Earth or bumped into us and pushed us towards the Earth. But then came Newton, and Newton went much further than Descartes on the plane of mathematical description of phenomena, but he had to relinquish any explanation of the type of Descartes. He didn't try to explain gravitation by means of bumping of particles into the Earth or into the objects that fall onto the Earth. But he explained...
motion of celestial.
Celestial slab nam yo bitje. Celestial slab nam ko kola yo de ni de gamma ta. Terrestrial slab yo sala yo de.
Okay. So Newton renounced explanation, mechanical explanation of gravitation, and he just posited a mathematical law. This mathematical law was amazingly efficient to predict everything. You could predict all the motions of all the planets for 100 and even 1,000 years, and you were perfectly exact. Yet he had no explanation of gravitation, only a mathematical law. So apparently you have a sort of regression here. Before we had an explanation, and now with Newton we have no explanation. But we have a much better descriptive mathematical theory and predictive mathematical theory. Now, according to Bohr, quantum mechanics, for instance, is a good case of that. Physical theory is not even a description of phenomena. It's only of phenomena as they occur by themselves in nature. It is only a predictive tool, mathematical predictive tool, in order to predict what? Experimental event in the laboratory or technological event that you could deal with in your laboratory also, or in your workshop. Okay, so you see a sort of progressive decrease of the scope of theories but a progressive increase in their efficiency. This is very fascinating. The more the theories are efficient, the less they pretend to make us understand the world as it is. Okay, now let's understand another point, another pedagogical point I want to make. It is often said that the interpretation of quantum mechanics is a problem. We don't know how to interpret it. So what is the difference between a theory and its interpretation? Now, a physical theory basically is a mathematical framework, especially according to Newton or Bohr, a mathematical framework to describe or predict phenomena. It is made of laws that connect variables. What is a variable? It's a value of a measurement. For instance, you can measure length, or you can measure velocity, and the value of the length you have measured is a variable. The value of the velocity you have measured is a variable. So a physical theory is made of laws that connect variables. For instance, classical mechanics is exactly of this type. It says this, a law of classical mechanics does the following job. It says, if you know, because you have measured, that position of this body is p0, and velocity is v0 at initial time t0, then under certain circumstances, you can calculate that the position and the velocity will be this and this later on. So it's a way to go from one.
대시 잡아야 겹토에 있는 것도 총총치 이내 양디 배주체네 디 수징 캐주다 자주 망보지 그 프레딕체도 있는 것도 여러 인자스 다다는 디 프레딕체도 다양 것도 매스매틱 배주지 거봐 다다는 디 변나 로그 다르지 장신 지겨나스 다 장신 제별값이야 당부대 나도 용세 사지들이야 포지션 제 비체 위디 다디 다당에 교류체 때도 고추도 가겠다 나는 교세요 말아 근데네 티디 나당에 뒤치체 다 디게디 고 당부 쭉쭉을 가리바 하고요나 아니 교세다 뒤갑다 디게디 돈에 아니 체제제 아니 주주 가서 가면 되지 나눠야 아니 다른도 다 가질래 두고 그랬어 지지 아니 체잡도 그러서 다 응지 돈에 대시잡도 그랬어.
For example, if I tell you, okay, I've thrown this ball with this velocity, for instance, 10 kilometers per hour.
Speed, yeah.
Yes,
The
the speed,
okay.
yes. And then I throw it out from that point at the top of this tower, this metallic tower. Yeah. Okay, if I throw it at 1.5 kilometers per second, it falls quite straight away towards the Earth. You can predict it with Newton's theory. But if I throw it much more quickly, then it becomes a sort of tour around the Earth. It becomes an orbit, you know. So here again, Newton's theory can predict that and describe the trajectory of the ball around the Earth. This is why it is so powerful and efficient. Now, okay, let's try to flesh out this mathematical skeleton. Namely, what is the view of the world that comes with this wonderful predictive and descriptive mathematical tool that enable you to predict the value of velocity and position from another value of velocity of position? In fact, there are many views of the world that fit that theory. There was the old view of the world of Newton, according to which the world is made of material bodies endowed with velocity and position. But there is also an alternative view that was formulated in the 19th century, which is completely different, which said, in fact, the world is not made of material bodies. In fact, the world is made only of energy. And sometimes there is a concretion of energy somewhere, and it gives rise to the appearance of a material body. This view was formulated by many scientists at the 19th century. Therefore, there are two conflicting views of the world that nevertheless fit the mathematical skeleton of Newton's theory. So you see that there is a difference between a physical theory on the one side, which is just a set of mathematical laws, and its interpretation, which is a view of the world. There can be many views of the world that fit this one mathematical skeleton. Okay, so this was the case with classical physics. It was no difficulty, actually, because each one of these views of the world fitted perfectly well, no problem. Only their multiplicity was a problem, because why many rather than one? Now, what is quantum theory? Next question. Okay, I will skip the history because it would be long, but I would like just to tell you that in fact quantum theory is simple and understandable. Maybe that means that I don't understand quantum mechanics, but no problem. I accept that. Quantum theory is only a mathematical scheme to predict measurement outcomes with certain probabilities. You have, for instance, in quantum theory, a symbol which is very well known, the symbol psi, which was actually the wave function according to Schrödinger. So you have this symbol psi, but it is used for only one purpose. It's to calculate the probability of finding one event. Full stop. Yes.
Symbol symbol of this. No.
Now, once you have the initial function psi, then this initial function psi enables you to calculate the probabilities of the measurements at time 0, namely initial time. But you need also an equation that gives you the same predictions, not at time 0, but at a later time. And this is called the Schrödinger equation. Then the Schrödinger equation modifies the psi function and turns it into another function that enables you to calculate the probabilities of the measured phenomena at time t. That is all that is to be known of quantum mechanics. Everything is in it, only the mathematics is missing. Okay? So,
Someone is wondering whether you've actually simplified it or made it more difficult.
I'm sorry.
Yes, okay.
I made it as simple as I could, but of course, it's quite difficult to go further, I think. Now, there are many interpretations.
Michel, just to go back, so your claim is that quantum theory is what? The essence of the quantum theory is simply this equation?
Yes, yes, exactly that. It's just, you know, a psi function that enables to calculate probability and an equation of evaluation of this psi function that enables you to calculate the probability not only at time 0, but also at later time. And that's it. Nothing more to quantum theory.
The quantum 구조나로야 중원되게 the probabilities.
probability study.
That the 처바시에게 답시에레스. That the 토리아 지겹단디. That two is probability. But that the 배샤남 유베나 생기던 걸 안게 된 거를 세저와. That the 지단식은 자자가 좀 납주지 생기되어서 자장업 주지 안게 되었을 거와. That the probability that 지겹이나 quantum theory probability 지겹고 two 다달이야 probability 가져요. 좀더 마세베 마음배 two 되지 갑이야. 이 probability 되지 어렸지. 이 지겹토야디 quantum 그토는 연구어렸어.
So,
So am I right in thinking that your claim is that quantum theory makes it possible to predict probability outcome not only at a specific time, but also
at later time.
a later time?
That's the reason why it is predictive. It can enable us to predict future results of future measurements. And this is why
But
it is
only
so
in
powerful.
probabilistic terms.
Only probabilistic, yes.
그렇죠. 간다 제 probability 그 돈에다. 다 데레다 간다 타치둥에 봐 말아봤다.
probability로.
So this is all what there is for the mathematical skeleton of quantum mechanics. But now you want a view of the world that fits with it. You want to say, okay, but what is this function psi? What is it? What does it represent? Is it a reality? Is it not a reality? Is it just a symbol that enables us to calculate probabilities? That's the question. And therefore, many scientists try to ask this question. What is psi? What is this mathematical symbol? What is the world made of? Namely, if psi is a description of the world, what is the world? Well, there are three types of answer, actually. Three types. One, I will skip a little bit, but one is that psi is all the reality. In fact, all the reality is made of a wave, which is described by psi. Schrödinger, the inventor of the Schrödinger equation, thought this way. He thought that, in fact, there was nothing else than the wave.
사이즈의 이 wave 그 전도체 아니 간다다 직 수ting 그 탐제 랍 그 단위레스 단어 그 단어 믹스해데 단 quantum mechanics 전도체제 wave 저바 딜레 투버레스 제니 사이즈의 따티기 장마 청구요레스 랍레스.
So, now, many other scientists, present scientists, believe the same type of thing. For instance, the Everett interpretation is very much similar to that. But I skip that. I don't care about that.
Galaxies 찍찍도 때문이나. 패시 왜 소리도 와.
나래.
다 전부 수준도 더 때.
나래. So in fact, if you look at
그런 아주 미글웨이.
나래.
왜 소리도 와.
So if you look at sort of the cosmos from a
Yeah.
vantage point of view, like in the image, say for example, if you look at the Milky Way, there seems to be almost like a kind of a wave pattern there.
Yeah, absolutely right. Yes. Now, of course, this wave of which we are speaking is not a visible wave. That's the point. But it is an inferred wave that enables us to calculate many things. And therefore, since it enabled us to calculate so many things, Schrödinger believed that it was, in fact, an adequate description of reality, and therefore that reality was wave-like, was made of a deep wave, invisible, but causing many effects. The second interpretation is that, in fact, the psi function is just a mathematical symbol, nothing more, and it's just here to make us calculate the probability of presence of particles. And therefore, only particles exist, and psi is not just a mathematical symbol. So either the wave is all the reality, or the particles are all the reality, and the wave is just a symbol. And also there is a mixed conception, which was typical of De Broglie and Bohm also. Which said that in fact there were the two things, half wave and half particle. That the particle was in some way taken by the wave, it was piloted by the wave, and therefore the wave was used by the particles to guide itself through the world. So you have these three interpretations. These three views of the world. Either the world is made of a wave, either the world is made of particles, and in fact the wave is just sort of mathematical symbol, and either there are two realities, half wave and half particles. Now, these three views of the world offer a lot of paradoxes. If you try to stick to them, you land into a lot of paradoxes. I just skip the paradoxes because it would be too long and too complicated. I just realized it. But maybe there is a fourth possibility, a fourth possibility. This possibility is very challenging, but I offer it to you. It's that quantum theory says really nothing of the world, nothing of what the world is or is not. It just offers us a tool in order to orient ourselves by probabilities throughout the events that we meet or the phenomena that we meet in the world. Of course, it seems very counterintuitive. Quantum theory is an amazingly efficient theory. Everything here is based on quantum mechanics. Many elements of this computer are based on quantum theory. There are lasers. There are so many things that depend on quantum theory and that are so powerful. How is it possible that a theory that is not describing anything of the world is so powerful and efficient? It sounds strange, but I offer you a comparison. Let's take, the insurance companies. Insurance companies must know how many accidents there will be during the years to ask people the right amount of money to insure themselves against the accidents. Now, how do they do? Do they know which accident you will have next year? Obviously, no, not. They don't know the nature of the accidents you will have next year. But they use a powerful tool which is called statistics. And with this tool, which says nothing about the nature of the accidents, yet they are able to predict the number of accidents, approximately, of course, during the next years. It could be the case that quantum theory is this kind of theory, which is very powerful on the statistical level, and yet very weak on the descriptive or explanatory level. Okay, well, Heisenberg and Anton Zeilinger also were two people who were very close to this position. According to Heisenberg, you cannot say by means of quantum mechanics what happens in the world independently of your intervention, of your experimentation, of your observation. You can only say what will happen with a certain probability in the laboratory when you will observe it. And therefore, the verb to happen, according to Heisenberg, the verb to happen is restricted to the observation. Nothing more. You cannot say more. You cannot say anything beyond observation with quantum theory. According to Anton Zeilinger, who should have been present actually, quantum mechanics is a theory of the limits of available experimental information. It's not a theory of what the information is about. It's just a theory of information itself, nothing more. So, playing with words, I wish to offer you an attempted, very daring interpretation. Maybe quantum theory has revealed us that nature has no intrinsic nature. Maybe it's the true revelation of quantum mechanics. It's not a revelation about the nature of nature, but it's a revelation about the fact that maybe the nature has no intrinsic nature. This is a possibility. Now, this is a deep problem with Western culture.
Quantum theory tana kashes na yugu nelu tan reject to mare deshe jabe de quantum theory lega mare quantum theory and che je da ani probability the kind of jingwen da che chajin res la me jig da yang kashi probability the kind of quantum theory the yugu rangxin ran sheba chigi ores de zeni che da tanda Heisenberg da Anton Zeilinger, niemand dramsala bin in der Konare. Die Konage sundan chebena, yuge nejusan shege yo maris. Ko yulia takba cheje, ani de cheje age. Chungwa de gite kandeji chungres di chere. Tati jin Koran samdang da chebena, cheba de gite cheundu kal peje quantum theory ge tudun rabdalia. Yul rangshi jitu mo mebade. Denga medros.
So this is a very great challenge for Western thought. Western physicists have tremendous difficulty to accept such views. They don't even consider that, very rarely. Only, you see, I could quote only 2 physicists, and most other physicists are very much against that. For instance, people say very harsh things against these strange physical theories, such as quantum theory, that apparently has no way to show us a view of the world. For instance, according to Isabelle Stengers, a Belgian philosopher, many physicists think that quantum theory has betrayed the ideal of science, because the ideal of science was to reveal the nature of things, whereas here it's silent. It cannot say anything, just say probabilities of events. René Thom, who was a French mathematician, was very, very aggressive against that. He said, in fact, quantum theory is the scandal of our century because it has betrayed the ideal of science. It's terrible. Okay, now, my personal view is that we must be quite prudent. Namely, should we go on with the ideal of science, even though it brings so much paradoxes, or should we drop the ideal of science, provided it gives us some clarity? That's the 2 options, I think. If the dream is suspended, much clarity comes. But of course, the dream was so dear to so many of our French scientists. Now, I think for Buddhists, it should not be a problem. For Western scientists, it is, but for Buddhists, it's not. Because, first of all, I would like to insist on the fact that maybe the reason why quantum theory is so powerful is precisely because it's not specific about anything. It's because it's so general. It covers all sorts of events in all sorts of domains, just calculating the probability of these events. One has showed very recently, it's a very recent work, 2 or 3 years ago, that quantum theory can even be applied to human sciences. It can be applied to linguistics. I could explain that to you later. It can be applied to semantics very efficiently. It's the same theory, and yet it applied to several domains. Why? What is the common point between microphysics and linguistics? The common point... The common point is that in both cases, you have relational phenomena. Only that. Only common point. Now, from a Buddhist stance, and I chose Dogen, the famous Japanese monk and philosopher. Very interesting. From a Buddhist stance, it's not necessary to go very much beyond what there is, what is immediately given, beyond the freshness of the quality of presence. You can, or you should, just appreciate suchness, tathata, in Sanskrit. What is given, immediately given, and not go beyond. And just describe what is given, maybe, but not try to imagine what is behind the veil of appearances. For instance, Dogen said, this entire universe has nothing hidden behind phenomena. There is no veil, no necessity then to remove the veil to see behind it. Just see the veil as it is present here. And what science does is exactly what Dogen described, namely, unfolding these phenomena in the most profound depth, and therefore be able to describe them in the most precise way, but not go beyond it towards a possible nature of things. Okay, I think I will conclude on that.
Thank you very much.
Thank you.
Wonderful.
Your Holiness, I don't know whether you would like to respond to this, whether you agree with Michel that there is some similarity, some meaningful similarity here between his interpretation of quantum mechanics and the Buddhist philosophical tradition? This seems like a very big and bold claim.
Yeah.
This reminds me, some time back, I think at least maybe 20 years ago, 15, 20 years ago, in Delhi, one occasion, one Indian nuclear physicist, Rajaratnam or
Rajaraman.
something.
Rajaraman.
Ah,
Rajaraman.
That his nickname, usually people call India's Sakharov, because he was one of the scientists who built India's nuclear weapon. So she told me quantum physics in the world, in modern world, this is something new, very new theory. He found the essence of that concept. He found already in Nagarjuna's text, some writing. So that's 2,000 years ago. That is suchness says only. Tishini.
No.
So in Buddhism, in particularly the Nalanda tradition, there are 4 schools of thought. So except the Madhyamaka, even within Madhyamaka, there are different sort of concepts. So basically, those are the school of thought, which essentially believe something
Intrinsic existence.
intrinsic existence. So they takandadina yujungane 직다 주위에 가서 그게 랑섬치 랑겨치 주위에치 시샤 제인데 아니 잡아서 제인데 녀도 사오시지 걔도 뭔가 태어나지.
So within the history of Buddhist thought, there were 4 main primary classical Buddhist schools of thought, and except for one of the branches of the Madhyamaka school, middle way school, all the other Buddhist schools' view of the world, particularly the physical world, was really grounded upon some kind of quest for the ultimate
both physical world
and the
mental world.
And the mental world. Sort of driven by this quest for seeking the ultimate constitutive elementary blocks, which are somehow have an intrinsic existence, an essence by virtue of which they exist. So once you go through that line of inquiry, then eventually you run into all sorts of problems.
Yeah.
So then the 4th Madhyamaka philosophy, so without investigate these things which actually is the effect, these are reality. Okay, it exists. But if we investigate what is the reality of that, then we can't find. So then nothingness. Right. So the appearance due to many other factors. If we investigate the object itself, we can't find. The very nature of the existence of these things are due to other factors, not by itself. So our sort of investigation is focusing on the particular sort of the subject. Right? So since its very existence is due to other factors, not itself, so we can't find.
That's right.
That does not mean non-existence.
Nothing
That's right,
exists.
yeah.
Oh,
Nothing exists.
Yes, exactly.
It is fact. It is work.
Yes.
So then, conclusion kareta, only yadana karisana, the mere designation.
So then the question is, in what sense can we say they exist? What is the mode of their existence? Then we can only understand in some relational terms or by mere designation.
Oh,
That's right.
다양 르 딱sel로 열어서는 말다세요.
No.
르 딱sel로 열어서는 열말이세요.
And then another question could be raised. In that case, whatever mind constructs, does that mean it exists?
Any mental objection, because mental
Mental object.
mental projection,
Not really.
does it
Does it
exist?
exist?
No.
Then the answer is, of course, no.
어, 탄협에 탄협도 자신 주바. 대로 탄협에 삼아시지 민우가 듣고 갔다.
So it's not only should it be something that is kind of, affirmed by a kind of a consensual convention, but also that the reference of that convention should not be something that can be contradicted by another valid convention.
Right.
So
Right.
very similar, the
Very
scientific
similar.
sort of research. One scientist to find something, you will not sort of decide.
Right.
But you see, another sort of
Confirmation,
repeat tested that, and also some other. They all found similar. Then decide that's true. So that are tiny bit samashan.
So this is what is meant by the second criteria, that it should not be violated or contradicted by another valid cognition.
Right.
That's right.
So
That's right.
이거는 내가 찍디 등등 주식을 준비해 좀 메뉴 봐. 사실 안에서도 가가.
And then, of course, in the Buddhist text, there is a third criterion added to this, which is that it should not also be negated by an inquiry that searches after the ultimate mode of existence as well. But that, of course, takes us into a Buddhist domain,
I see.
Buddhist philosophical domain.
Yes.
부드스 나로리아 야 타니베 쳔가셰 딱든 전에 니베 루스 전에 샤바 인도자네 딱고 단단 지르고 있는 거.
So, for example, within the Buddhist world, from the Madhyamaka point of view, since many of the postulates by other schools are essentially, arrived at as a result of a form of inquiry that was actually seeking for their ultimate mode of existence.
So seems, of course, in detail there are still differences, but broadly, I think the Buddhist Madhyamaka philosophy and quantum physics we can shake hands. Isn't it? What do you think? Do you think?
I think so. Let's shake hands.
Not that way.
No.
So in any way, these things are really wonderful. I really feel human intelligence is such sort of ability to think, to investigate. So these thinkers, really great,
Thank you very much.
great. I think we can say that a human being,
So we can see in these examples of the great thoughts and ideas presented the fruits of the human thinking,
Yeah.
great thought thinking.
then meantime, we must have sort of feeling, these are also human beings, nothing special. So we also have the ability, whether we properly utilize this ability. If we consider these are something Buddhists say manifestation of a Buddha,
Yes.
we are not like that. Then so
So the point His Holiness is making is that, regardless of how much we might admire these great thinkers, we should never lose the sight that we too are human beings who have the same potential.
Yeah.
Otherwise, there is a danger of excluding ourselves from that ability. Because sometimes, that may seem like a humility, but also actually sometimes it could be just a cop-out.
Right.
Yes. Yes.
Well, Your Holiness, you suggested that maybe in your retirement you would like to become a scientist with Richie perhaps in his lab. but there's also the possibility of physics.
We can start a bidding war.
But Holiness, you can also become a philosopher
Yeah,
in,
yeah,
my, in my team.
그냥 저 quantum physics 타는 제 이나도 particle 보시 쉐거다. particle 타는 제니 내가 로드 많이 충으로 돈다. 이는 게
So, you know, I mean, maybe His Holiness will accept this invitation on the condition that you spoke about how, as a function of special relativity, you know, the time can collapse,
particle.
and then particles can, you know, collapse and so on.
Yes.
So maybe you could decrease His Holiness's age. You'll be able to.
That I will work.
To travel very fast,
Yes,
is that
I
right?
think Richie and I can both work on that. We'll come back next year.
그러니 손대더니 저
It is an interesting feature of science internationally, Your Holiness, that it is, in principle, open to everyone to do. And many, I think my colleagues will agree, many people who become distinguished in science do not come from particular scientific backgrounds.
That's right, that's
They
right.
do not have parents who were scientists for many generations. They got interested, perhaps as children, as you indeed did, and just followed their dream and ended up with the Nobel Prize in some cases. So I hope this is that people understand this, the people who are listening to this meeting, and there are many in another building, that there is an opportunity here, in principle, for them if they really want to do this, because science is open, it is not closed.
True, absolutely. Absolutely.
So I wonder, with that, whether we should move to our third talk.
That's right, that's right. Next. 가. I would like to, I prefer you remain here.
Thank you. You're very gracious,
You can
Jimpa.
I really enjoy these talks and also every occasion learning new things. Now big question whether these new knowledge remain here, how long, that I don't know.
This helps slow down aging.
Oh,
It helps to slow down aging.
Mike.
right, that's good.
This we know.
Yes, I think
how
it's
do I
quite
get
true.
to
You
my-
see,
Just
brain
have to,
remain very
close
active,
this.
always thinking.
Exit show.
That also, I
Read
think,
from this,
something like
and then you should be
refreshment
able to find yours.
or genes of the brain, I think.
Can you see yours? Oh, sorry. Okay.
Your Holiness, the task I have this afternoon is to make a short presentation, partly to draw parallels in the Buddhist thought to the two presentations, wonderful presentations we have heard from our scientific colleagues, Arthur and philosopher of science, Michel. What I would like to do is, of course, I cannot do justice to the more than 2,500 years of history of very serious Buddhist thinking in this domain. But at the same time, I thought I could give a little bit of glimpse of the kind of questions the Buddhist thinkers were, struggling with, and the kind of the amount of thought Buddhist thinkers have given to this quite early, from a very, very early stage. Before I begin, one of the things that I wanted to point out is that listening to both Michel and Arthur to your presentation of quantum mechanics as well as special theory of relativity and the challenges posed by the kind of the new physics. In fact, the challenges it poses to our very conception of what constitutes matter, our very conception of what is a matter and what is not a matter, which is so dominated by our everyday language of objects, things, and properties and attributes, and the kind of the paradoxes it leads to, as His Holiness very, kind of pointedly, shared with us. And this is something that has been very acutely felt in the Buddhist world as well. among the Buddhist classical thinkers, there were four main schools which came to be categorized. And except for the Madhyamaka school, which is the middle way school, most of the other Buddhist schools really felt the need to, in order to have a coherent worldview, a theory of both matter and the mind, there needs to be a kind of a reductionist approach made to really reduce from the macroscopic level of everyday experience to tease it out, divide it up, to look at its constitutive elements, go down another level, tease them out, unpack it, go down another level, unpack it, tease it out, so that ultimately you can get to a kind of a starting point. It's a bit like what Descartes was trying to do. It's a foundationalist. And then these, but again, the Madhyamakas pointed out that kind of project is actually quite unhelpful. So you can see that the tensions that we are witnessing in the world of modern physics is a tension that has been felt in the Buddhist world quite early. So what I will do is, I will give a very, very brief background for the benefit of scientists and scholars here, those who are unfamiliar with the history of Buddhist thinking. Much of these theory of matter and consciousness really begin to emerge, the systematic theory, in the early kind of Abhidhamma texts. And here, of course, the dating, there is some dispute among the modern scholars. But the earliest one that we know is Abhidhamma Hridaya, which is really attributed to somewhere around 1st century before the Common Era. Now, and this is the text where we begin to really see the explicit usage of the term dhul, atom and particles. So as I said before, it's a reductionist approach. It's ultimately is a search for ultimate constituents of reality, from the gross level going down to smaller and smaller and smaller at different levels of reality. It ended up creating a pluralistic taxonomy of real entities. It's known as Dharma theory in the Buddhist studies jargon. And it ended up taking an atomistic theory of matter. So, and then the constitutive elements of these are, these are kind of the simple indivisibles, partless particles. And they ended up with a list of 8. 4 great elements and 4 derivative elements. Now, the derivative elements includes some of the properties which in Western thought would be regarded as secondary properties on Galileo's list. Sound is not there. Touch and order and so forth. Sound was excluded because sound was really thought to have no ability to propagate its continuum, because it rides on wave, and wave, does not continue. Wave is just one pushes the other, and sound therefore cannot propagate in a kind of a continued fashion. Then the list of the elementary particles, they made a distinction between, what is called Zedul Tarab. So these are really the ultimate constitutive elements, and which, for want of a better word, I've translated as elementary particles. This is the smallest unit. And then atom is really thought to be a composite of those smallest units, at least 8 of these. And then molecule is kind of a 7 of these composite atoms. So that was the kind of the unit that they built up. And then there was a very sophisticated, complex list of how the aggregation takes place, how it gets grosser and grosser and grosser. It's a very, very complex explanation. And the main point is that the elementary particles are ultimate indivisible. So this is really the final end. So you cannot go beyond. And now, then the question is, when within this atom there are 8 of these elementary particles, then the question was, how are they relating to each other? They were thought to be not touching each other, but then the question is, how is it they don't disintegrate? It's held by air. So there was, that was the, in very, very crude terms, summary of the early Buddhist Abhidhamma theory of atom. We could see a more sophisticated take on this, called what we might call a Sautrantika revision. Sautrantika is another school. They maintained the reductionist approach, but they rejected the plurality of entities. They wanted a much cleaner, efficient system. So they defined reality, or ngopo, in terms of causal efficacy. And they came up with a simpler taxonomy. So basically 3 classes of phenomena: matter, mental, and their attributes. And then they came up with this idea of degrees of reality. So they made the distinction between substantial reality versus real in name and concept only, so which are constructs. So substantial realities are entities whose identity, in order to conceptualize, does not require the conceptualization of something else. So whereas those that are real in name and concept only, like person, the notion of a person is the second category, because notion of a person, in order to have it, it presupposes a notion of mind and some bases which are not person. Then they also maintained they retained these ultimate irreducible elements: indivisible particles, partless particles, and indivisible time. So with relation to matter, the way in which it was divided up was according to the indivisible atomic process, and ultimately getting to the indivisible particles. And for consciousness and mental processes, it was divided up from the grosser level of conscious experience that you can report down to going ever more subtle levels where you can divide up the duration, time, into eventually identifying an indivisible point of time. So you can see the sophistication of the thinking behind all of this. And compared to the other Abhidhamma school, Sautrantika had a slightly different take on how the particles within an atom relate to each other. So they accepted they do not touch each other, but at the same time, they said there are no spaces in between them. So that was how they maintained. Now here, you can see that this is a Buddhist essentialist school, and although their approach is reductionist, one thing that I have to clarify to the Western scientists and scholars here is that when I talk of Buddhist reductionist school, none of the Buddhists ever can be characterized as a reductionist in the Western sense, where you reduce even the mental to the physical. No Buddhist schools ever did that. Other than that, Buddhists would have a reductionist process for the mental world and reductionist process for the physical world. But the mental is never reduced to the physical. So that's an important caveat that I need to make. But otherwise...
That's very important.
Yeah. So otherwise, the approach is reductionist. Now, early on, although this kind of theory, this way of looking at matter became very, very influential, quite widespread, but the critiques of this kind of approach emerged quite early. Nagarjuna was the founder of the Madhyamaka Middle Way School, 2nd century Common Era. Aryadeva was his immediate student, who was also a great philosopher and a thinker in his own right, in addition to being a famous student of Nagarjuna. Just for the sake of example, I wanted to give you a taste of what kind of critiques were leveled against this idea of this atomic theory. One argument, and all of these, most of these thinkers really didn't really bother that much with the specifics of the detailed theory of the aggregation of matter from the atoms and so on, but rather they all critiqued the final conclusion of arriving at the postulate of indivisible, ultimate, real entities. So here, one of the arguments is this. This is from the argument of incoherence, and basically they are arguing that the idea of indivisible, partless particle just doesn't make any sense. It's incoherent. Because if it is a particle, then it's a part of a matter, and matter presupposes some kind of spatial locus, although this morning Arthur said that you can have two things at the same spatial locus. And then the argument goes, and anything that occupies space entails, at least at the conceptual level, different spatial dimensions. And anything that has a spatial dimensions cannot be a simple indivisible element. So the idea is that if it is, in order for it to be conceived as matter, you have to include the idea of having some kind of locus. And if it has a locus, then it has a spatial dimension. And if it has a spatial dimension, then it will have different dimensions. So then that idea that it is an indivisible, simple element just doesn't make any sense. So that was one argument. The same argument is presented in 20 stanzas, which is the more famous one, which most people know. But Aryadeva is 2 centuries earlier, and there is exactly the same argument in Aryadeva's text. The second argument, yes, His Holiness was saying that the 20 stanzas exist also in Korean tradition as well. This is by Vasubandhu, who was a very influential Buddhist teacher of the 4th century of the Yogacara school. Aryadeva also comes up with another argument, which is to really kind of argument from the causal agency, because again, he's arguing that if this idea of indivisible simple element in a particle makes sense, then you wouldn't be able to account for the aggregation because there is no causal agency that could be attributed to it. So the argument runs in the following way. If the alleged elemental particles are ultimate indivisibles with no dimensions, there would be no causal activity at all, which in turn would make it impossible for aggregation of particles to form material objects to take place. So one is from the causal point of view, the other one is from incoherence. So there are numerous other arguments like that, which are really critiquing the fundamental kind of standpoint of this reductionist approach. Now, the Madhyamaka that His Holiness referred to is an important school, and particularly for the Tibetan tradition, it is the most influential school. In fact, it reminds me of an ironic line from Kungtang Rinpoche, a 17th century a Tibetan author. He says, he's chiding his Tibetan colleagues. He says that in India, at least, the Buddhist thinkers were honest, that each held their own philosophical viewpoints according to their own kind of inclinations. Here in Tibet, all of us claim to be Madhyamaka Prasangikas, but how far our views are Prasangika is open to question. But in any case, Kungtang Rinpoche, in any case, Madhyamaka is the most influential school in so.
I think it's a Tibetan case. Shantara is the Quran. Madhyamaka philosopher.
So His Holiness is saying that one of the key individuals that was instrumental in establishing Buddhist scholarship and Buddhist studies in Tibet was Shantarakshita, a great master from the Nalanda monastery, who was himself a great Madhyamaka thinker as well as an authority on Buddhist epistemology. That's why the study of Madhyamaka and epistemology became so influential in Tibet. So, in fact, Padmasambhava was also a contemporary master of, together with Shantarakshita, who was also highly instrumental in ensuring the success of establishment of Buddhism in Tibet. But Padmasambhava's role seemed to be primarily in the domain of helping with the ceremonies and rituals and ensuring the successful establishment of Buddha Dharma. Whereas when it came to actual ordination, establishment of the ordination of the monastic order, giving classes and imparting the Buddhist knowledge and philosophy, it seems Shantarakshita played a very crucial role. So the Madhyamaka middle way school.
So Shantarakshita is at that time, 8th century, one of the best sort of the thinkers or philosophers
Naren.
of Nalanda.
Nalanda, yes. So you heard that, yeah, okay. Shantarakshita was, in the 8th century, one of the greatest philosophers and thinkers of the Nalanda tradition, Nalanda monastery. So, in fact, Shantarakshita was, so important that a whole new strand of Madhyamaka school, sub-school, emerged out of his thought, which is the Yogacara Madhyamaka school. So he was not just any philosopher or thinker, but he was, in fact, a founder of a sub-school of the Madhyamaka tradition. So to continue, Madhyamaka, as I said before, does not really take issues with the specifics of the atomic theory, but rather examine the fundamental premises underlying the entire project. And it argues that the Buddhist essentialist and the reductionist really project is an essentialist, objectivist, and reductionist project, which is searching for the final, simple, irreducible elements that would constitute the ultimate building blocks. And once you find that, and then you start building up like a structure, a cohesive picture of world. So that was one of the main, in some sense, diagnosis. Another thing that they pointed out is that often that kind of project goes hand in hand with the corollary in the epistemology domain, which is a foundationalist project where you seek your knowledge, seek to ground your knowledge to, again, some indubitable perception of real facts in the world. So you can see there's a sort of a Cartesian, similar to the Cartesian project. So just as you have in the ontology, there's a kind of a reductionist, an objectivist attempt. Similarly, in the epistemology, there's a foundationalist approach. And so together, it's an attempt to really, it's a project to look for an ultimate description of reality, a kind of a final description of reality. And so the Madhyamaka's critique to this entire project is really focused on questioning the key assumption underlying all of this, which is a belief in some kind of essence or intrinsic existence, by virtue of which things are thought to possess their existence as well as their identity. So things are, they have some kind of objective inherent existence, and it is this essence by virtue of which things are then thought to not only possess their existence, but also their identity as well as the kind of properties that they are supposed to have. So, for example, Nagarjuna's fundamental stanzas on the middle way, Mula Madhyamaka Karika, Tsawasharap, is in 27 chapters, and each chapter takes many of the categories of both epistemology and primarily kind of metaphysics and ontology, like time, person, agency, action, and so on, and take them one after another and critique the underlying assumptions of some kind of intrinsic property and intrinsic reality. Now, then the question is, okay, so the Madhyamakas have basically pointed out that this project is not really that helpful. It is so fun, they critiqued it. Then the question is, what do they propose in place of this? It's not simply enough to simply critique it and then leave it there. So their proposal is really presented within the framework of the theory of the two truths. Now, theory of the two truths is universal in the Buddhist world, and to some extent, other non-Buddhist classical Indian tradition also use that kind of framework. But it is in Madhyamaka that the theory of two truths is really used. One could almost say that the reason why the theory of two truths was developed in classical India is to really kind of reflect the recognition very, very early on there is a gap between the way we perceive things and the way things really exist. And to explain that disparity, this theory emerged. So therefore, His Holiness would like to share with the quantum specialists that if the quantum theorists take on board this framework of the two truths, then you will have easier time. Because otherwise you run into a problem, because when you try to search for the reality, then all your conventions start getting wobbly and becomes very problematic. When you develop the conventions and try to develop a description, then you run into problem with actual reality. So, however, it is in Madhyamaka thought. Where is this coming from? Yeah. However, it is in the Madhyamaka thought that the theory, the full force and the potential of the theory of the true truth is really used to really, kind of get around this problem. Michel gave the example of Dogen and already referred to that term tathatha, thatness or suchness. So basically, what the Madhyamakas are arguing is that really it's not possible to develop any ultimate description of reality. That is final description. In particularly, basically, Madhyamakas are arguing that you cannot really have an ultimate, final, comprehensive description of reality that is really ultimately true, because all the categories of dichotomies really break down when you get to the ultimate level. Even causality breaks down at the ultimate level. So therefore, no, so the ultimate truth is beyond conceptual elaboration. So although one may be able to talk about it, but you can never really describe it exactly as it is. It is where all the verbal proliferations really come to an end. And this is the famous, the silence of the noble ones. And therefore, it is referred to as emptiness and thatness, and sometimes the end of reality or reality limit. So, on the other hand, the conventional or the relative truth, now it is there, we can then use all the conventions, all categories of cause and effect, subject and object, identity and difference, become meaningful on this conventional relative truth level. So now it is on this conventional level, now our descriptive system actually now is a constitutive part of reality. So to speak of reality independent of our description is essentially meaningless, because as His Holiness earlier pointed out, that many of the properties are really created by the human mind to make sense of our experience of the world. So these are attributes that we experience and we perceive, but actually they are constituted part of the reality of the world that we live in, but they are created by ourselves. So it's a much more kind of sophisticated understanding of reality and our relation to it. So what is real is really, and what is not, is defined by their transactional efficacy, and His Holiness already gave the criteria that it should be something that is affirmed by the convention, consensual convention, and it should not be contradicted by another valid cognition. So it's the transactional efficacy is really, and in some sense, this is getting not that dissimilar to what you are talking about, this instrumental attitude to quantum theory. Now, within this descriptive system, because it is within the framework of conventional truth, there is no ultimately real, irreducible, simple, independent entities. Because those kind of concepts only emerge as a result of looking for something that is final, that the real ultimate. So these kind of concepts have no place within that framework. And therefore, everything is understood to be thoroughly contingent and complex. And this is where Nagarjuna's text, particularly the Fundamental Stantos on the Middle Way, is a very powerful one, where Nagarjuna, not only in order to establish emptiness, uses huge amount of extensive reasoning, but also points out that you can take any concept. Any concept is thoroughly composite concept. It's a contingent concept. Generally we tend to think effects depend upon the cause, but not the other way around. But he would argue that the very concept of something as a cause already presupposes an understanding of its relation to effect. So if you go along those lines, there is not a single concept that is in some sense a discrete, simple concept. They're presupposed. And in some sense, this is not that, there's a little bit of similarity to what Wittgenstein talks about, kind of, the context that we already presupposes, the language, context. And then also, in the end, Nagarjuna, when it eventually talks about what is there, and he starts to describe what is there in the language of dependent origination. Pratitya samubhada, dependent arising or dependent origination. So in a sense, you cannot really disentangle the reality and even the identity of things, independent of, the other things that it is related to. So it's a sort of really quite similar to the quantum notion of entangled. It's a sort of a web of dependent origination. So therefore, not only with respect to their existence, but even regard to their very identity of what they are, as they are utterly contingent and thoroughly relational. And this relational, and as in the case of modern physics, it's a very difficult concept to try to get handle on. In fact, in Chandrakirti's commentary on one of the chapters of Nagarjuna's text, even suggest that we can completely recast the language of objects in terms of language of relations. And he gives some examples of very relational terms that we use in our ordinary experience language, for example, like long and short, and driver and cook. These are all terms that are very relative and immediately indicate their relativity. So for example, the term president would be relative to a particular office, and term cook would be relative to a particular profession. So term driver would be relative to a particular action. So in the same way, Chandrakirti, in his interpretation of Nagarjuna, seems to be suggesting that actually we can recast the language of objects to a language of relation. And it's the relations that are, a more helpful way of looking at the world. To be honest, I myself find that suggestion very, very difficult to grasp, but I think there is something in there, but I can't at the same time imagine a whole new language being developed where we get rid of the object language, but also talk only in terms of relations. 이게 본바다 지지 상황을 잘 자세히 줘 가르쳐 때 자제 그것도 되는데 단자. So in other words, what the Madhyamaka philosophers are saying is that reductionism as a method is not really an issue here, so long as it doesn't preclude the relationality of things. So one can still validly do this kind of reduction from the macroscopic to the smaller units and so on. But reductionism motivated by an essentialist quest for objective independent entities is really not helpful, and it's eventually is a doomed endeavor. And so within the framework of conventional truth, yes, our description can be fine-tuned, and one can also talk about correct versus incorrect descriptions. Because the conventional truth and the framework is a framework within which laws of the logic would operate, laws of causality would operate. So there is a method by which we can adjudicate. It's not purely a subjectivistic view where we do not have any recourse to any kind of objective criteria of evaluation. But that criteria of evaluation really comes from the fact that it is contingent to a conventional framework which presupposes a consensually arrived at convention, and which includes the laws of logic and causality as well. And thus, the Buddhist emphasis on trying to understand causality as far as possible, even at the quantum level. Sorry. So I hope I have done some justice to the whole history of Buddhist thinking. And you can see that at the end of this, you can see basically a tension which is there historically. On the one hand, if reductionism as a method is valid, then you would want to expect moving from the grosser level of everyday experience to a kind of a more minute level where we can eventually find something that is ultimate. But at the same time, if you end up postulating real, indivisible, ultimately real entities, then it opens up a whole host of questions about how do you understand their properties, how do you then understand the relational nature of all the things that they are, that are made from these supposedly indivisible particles. Sure.
Please. Could you use a mic?
And you mentioned in Tibetan tradition, or none of the Buddhist school is an attempt to reduce the mental to the physical. But in Tibetan Buddhist tradition, was there any an attempt to relate the mental to physical things? I mean, without reducing them fully, but to things like the brain. Was there any relationship thought to be between brain and brain stuff and the mental and mental stuff?
What?
Or body.
Body.
I mean, body in general, but brain in particular?
The brain is an interesting question because generally, despite all the great amount of energy expended on understanding mental processes and also theory of knowledge and so on in classical Indian tradition, interestingly, in the epistemological text, to my knowledge, I have not seen anywhere any awareness of the important role brain plays as a locus for human experience or thought. This said, interestingly, I have found in a Tibetan medical text, and particularly in the Vajrayana text, some awareness of the role brain plays in the arising of the experience of joy and suffering. So, which seems to suggest there was some recognition of the brain's role, but not in the epistemological tradition. But to respond to your question, one could argue, of course this is my own personal interpretation, in the highest yoga tantric tradition, there seems to be a suggestion. I'm saying suggestion because I'm not exactly sure, and I don't want to speculate too much in front of His Holiness, that there seems to be a suggestion that, the mental processes, even at the most minute and subtlest level, are in some ways inseparable from physical processes. But here, physical, of course, the conception of what constitutes physical has to be very different. And in the Buddhist language, Tibetan language, Buddhist language, we refer to it as wind, or an energy, or a wind. So every mental activity or mental episode or event is composed by two dimensions. One is the cognitive mental dimension. The other one is the mobility, moving dimension, which is the energy. And energy is the physical dimension at a subtle level. Energy is the physical level, a physical dimension, and the mental is, of course, the experiential dimension, and no matter how subtle you get, even at the point of death, where the subtlest moment of consciousness is supposed to arise, even there, the two remains inseparable, inseparable. So they are, in some sense, two sides of the same thing. So that view is there, but I haven't seen that in the philosophical texts.
Okay. Please. Yes.
Thank you. As Sudhijima mentioned, in Tantriana, this is, I think some of you may know, there are a lot of different deities. So it seems somewhere the deities' world, their own king or prince or queens or like that. Actually, not that. All, you see, symbolic way. About our body
Representations.
element. Body element. So one sort of the goddess Tara. Tara is the symbol of subtle energy. So subtle energy, as he mentioned, you see, the main sort of the ability is movement, or yuljuba.
So we explained the ability of the cognitive process, the cognitions, to be able to, to be directed. That ability is attributed to the wind dimension.
So you see that deity usually visualize here, head. So that symbolize head. Although you see no explanation about it, as you see those brain specialists, you see their knowledge is really vast.
Advanced, no? Advanced.
But the essence, you see, the mind knowing, movement come from here. So energy here. So I think indirectly, the Jew brain is the
So indirectly, it seems there was a recognition of the role brain plays in the experience, at least.
다 시에바 미주버사디 다 이시 미주버스로 다 닝걸스가 다 과르시하고 나 메신다디 다 곰점니 내리들이야 상고 세트는 곰이잖아 즉 소용야지다 즉 강소순이 즉 영화 캔사는야지 용되기도 하다 배나 대화리야 또무 곰니 최패야 즉 닝걸이 미고 때니 뒤르면 아주 용기도 하다 저상고 될이야 비전은 시험은 신경 싸워디디 코봉하지 되면 요 말이지 그 뒤는 내가 지어서
So
the dealing of further research 하죠 또
So if you look at say for example, the contemplative practices that are described in the Vajrayana text, which involve the kind
now
of
here I mainly mention Guhi Samaja.
In the Guhya Samaja Tantra in particular, there are forms of practices that involve application of mind and also energy at different critical junctures of the body. And these are referred to as chakras or centers. And so as a result of engaging in these practices, for example, at the point of navel, engaging in the tumu meditation.
This is the source of heat.
And so there is a real experience, effect that is felt at that spot.
No.
So at the heart, it's associated with the water element, and as a result of engaging in practices that involve focusing on that chakra, one can also experience certain dissolutions of energy, and as a result, the effects can be felt on those sites. So, although it is early days, but I think it would be helpful down the line to be able to do some research and trying to, it's not the case that if we were to open our body that we will find these physical kind of, chakras. But at least, as a result of practice, we can see effects felt on those specific points. So there must be something which perhaps could be a fruitful field of research.
So these things, the physical, the draw you do this.
So all of this is to say that there is a recognition of how intimate the connection is between body and mind.
Richie. Do you use it? Yeah.
No, not this one.
Which one was working? Just try it. No.
Can you put the handheld? Yeah.
No.
Your Holiness, you were referring to subtle energy, but some of the effects of the subtle energy are clearly manifest. They are apparent to the practitioner, and they, in certain cases, have actually been measured. And I just wonder if you can say a little bit more about how the distinction between subtle and coarse is actually made. How do we know that a particular energy is subtle? What is the definition of subtle? And is there a continuum between subtle and coarse, or is it something that is more...
Self.
Subtle.
Subtle.
No. Tanadi taragi yemje kanang yorba. That kanda long time nam gyuti gomja beton tongu yobote restaine. Ne tamo yema yengi. Chamo kanda jiga ton shagyo na. Ane tamo da rabani buti gyu manya bache dusya the yore. Rabe chamji gane ane lamsang tongje chaje ane tamo geya.
So both consciousness, I really don't know the exact sort of terminology, I don't know. The consciousness and energy always go together. So now here, very grosser level, and more subtle, and very, very subtle. I think at least we can say it's 4 levels. One grosser level, during all the sensory organs active, that's gross level. Now, dream state, a little subtler. Then deep sleep, furthermore, subtler. Then deepest or innermost subtle level is actually brain function stop. Clinically dead. I think we discussed something, which usually we call tuktam. The body element now completely ceased. Still, the body remains fresh. 2 weeks, 3 weeks, sometimes 4 weeks. So there's no other way to explain except the subtle mind still in that body. So where there's subtle mind? Here or here? We don't know. But training for that, sort of visualization is usually concentrated here. Grosser level, dissolve, step by step. Then finally, the subtle mind. So the deepest mind, no related with, not depend on brain. Like that. But I have no experience. So one time, I think in early, I think early 70, one letter my office received from Bombay. So I think some NGO, some organization. They asked, this is among Tibetan practitioners, some sort of mysterious experiences supposed there. So they want to experiment or investigate. So then my staff member asked me how to reply. Then ya mariselo tomorrow ya. Ya some zuzu amiduwa. So you the kijuris lo chain.
So His Holiness staff was asking him how to respond. So His Holiness said, since we cannot say that such things do not exist, but at the same time there were no any specific individuals which we could cite as an example, So His Holiness suggested that to write them saying that such a person hasn't been born yet.
Now 30, 40 years passed. So I think that same organization asked me, now sufficient time, 40 years passed, 30, 40 years passed. So I think there must be just someone at least. So 지상 안 주다 지금 롬니 개별 타마르디 라 롬니 개별 두든디 선을 요시되고 근데 뭐 딱 왔을 때 아다 가데 파라 삼거데 부디 소스다디 만주 탐메베 시반디 림베 소남친 졸람친 통놈 고놈친 사줄라모스도 파 직sab트 대베서 멤버 소수 규 니가리야다 규 가서 그게 내서로 셔도로 심을 타네 애는 라몽한테 샤워야 저기 자 드리고 더 공에 인지미지고기 nen다 기규에서 너무 거충으로 시안데 다들 기규에서 기르네.
So someone was saying that here there is a large monastic gathering, and I've often told them that ultimately the purpose of the classical Buddhist education is to really bring about transformation within oneself. And
so one thing I think, one unique thing about Buddhist practice, particularly in Nalanda tradition, is utilize human intelligence maximum way, through that way transform our emotion. So that's why you see these sophisticated sort of philosophy is mentioned involved.
So His Holiness was saying that he often points out to his fellow monastics that we should pay attention to what comes at the end of Heart Sutra, when it says gate para samgate bodhisattva, go beyond and establish the basis for enlightenment, and which really suggests the progression of the path towards enlightenment. And it is important for the monastic members to remember that when we talk about path to enlightenment, we should not have a sense of looking at a map outside, talking about some objective place out there for someone else, but rather that map should be turned within and try to bring about those progressive stages of transformation within oneself. And this is the way that one can genuinely make these things a reality.
Thank you. Are there any other comments that people would like to make, including from around the table, in the last few moments that we have before we need to break?
Your Holiness, I have a question or two. You talked about this self-transformation through the application of contemplative practices. Do you believe that whether it's Madhyamaka philosophy or whether it's quantum physics, they are challenging, very challenging philosophical demands? And we don't naturally think in this way. We think in the common thoughts and patterns of our lives. Will we at some point become so fluent and easy with these concepts as we are with the common? In other words, can we develop an understanding of quantum mechanics? Can Richard Feynman's claim be wrong?
단다 군주네 로녀서 간다 타르투 운데가 수수 로 장지 냠뇽 체고 가능 봐봐 디단데 왜 돈에 단데 맞지 우메 따와다 콘좀 그톤에 셰비고 셰바 띵사고 싶지 맞지 로레 차라가고 된데 지강에 연구하러 왔어 그때도 림베로 콤제 ben ume shune shebe tawe namsha de ge ani namshi chili yang ran jo sam kyuma tang ba na shin gi chik lubu yong ya ga tabshe yonas ta quantum sne da ya ume
I think that's the question. According to my own little experience, I start serious thinking about, the relative, according to Buddhist Madhyamaka philosophy, the relative theory. Since it is relative, therefore no absolute. So absence of independent existence or absence of absolute. So that subject, since my childhood, I think almost 15, 16 years old, I already sort of developed some interest.
Yes.
Then, actually, my daily practice is to analyze the reality, myself, my mind, or everything. That's one of the most important part of my daily practice. So now familiarize. Now last over 50 years. You see that firstly intellectual level, then gradually actually sort of feeling. Now see that 가서 the 정신에 봐서야 이 한도 로리야 즉 도저 전주의 난다. 이 ten to step in. 패즈 규모도서 지름이 잘.
So, as a result of this kind of prolonged familiarization and reflection on a day-to-day basis, so His Holiness was saying that when I, consciously bring up the notion of absence of intrinsic existence or emptiness, that immediately is able to kind of create a flavor so that his perception of the world becomes almost has this illusion-like quality.
So that the very purpose of that understanding is reduce the extreme view of sort of attachment and hatred, anger. All is very much based on mental projection. So mental exaggeration on the basis of appearance of independent existence. So once you really develop full conviction, no independent existence, then reduce the basis of exaggeration, right, mental projection. So that's the way to reduce destructive emotion. Destructive emotion based on ignorance. Constructive emotion based on logic. So that makes differences. So, but that's my secret. I do not want to share with scientists.
Well, I must say you're doing a very bad job of not sharing it with the scientists.
Your Holiness, it seems...
Actually, I always emphasize, we Buddhists, you see, we discuss these things, but we never intend to promote Buddha Dharma. I respect different religious tradition, Judaism, Christianity, Islam, Zoroastrian, different Hinduism, Jainism. It worked. Last 1,000 years, to millions of people in the past, not only in the past, at present, and future also. So from sometimes we a little bit sort of critical about some Christian missionary sort of worker.
Okay.
So our own sort of view, some of these sort of religious people actually making attempt to conversion. So first, in order to criticize critical view about them, you yourself must sort of follow, respect their religion. You should not make an attempt to conversion. So we must, in the philosophical field, there's big differences among these different religions. Obviously, God, Creator. In the Buddhist theory, no room that. So sometimes, one time, my American friend, a Catholic monk, really very nice person. He found, some of the Buddhist practice regarding practice of tolerance, practice of compassion, these things, and also practice of certain method of single-pointed mind. So we always happy share some of our experience, some of our sort of method. One day he asked me about the emptiness. Then I told him, no, this is not your business. This is Buddhist business. Because you see, that theory not fit the
Okay.
concept of absolute center sort of creator. So I do not want to create some kind of sort of the questions,
Not in-
their
okay.
own sort of
Doubts.
basic faith.
Okay. Okay.
So it is better to keep individual
Right.
individual business like that.
Your Holiness, this though, this absence of intrinsic existence that we talk about, these properties that common to Madhyamaka philosophy, and now also I think personally one sees these in physics. There are similar critiques of the essentialist view. I wonder if it doesn't have ethical implications, as you spoke about, that we no longer are basing our knowledge on a kind of ignorance or mistake, but it then has also consequences for other people. We're not grasping any longer. Is there an ethical dimension to this that could be a part, frankly, I'm thinking of your secular ethics, that there's a way in which the science can actually help lay a foundation for a secular ethical orientation? Is there an ethics?
안 되도록 이게 저희
랑시 매베드 제도가 현자 숙침부 용해 시드 매버 차기로 봤어. 근데
밴디 패진 찬스 다시샤 요도. 즉 quantum physics 다 같이 knowledge고 매베체. 그 직도 feeling이 여den게 지기. 그는 미지기 차당 유기에 그도를 the reaction condition도 response. 근데 quantum physics 게지 미싱이 지기 그게 absolutely something 되게 차당 유체에 그도를 response condition도 패지 다시샤요.
So maybe there could be an experimental opportunity here. For example, if you can find individuals who are not only intellectually kind of conversant in the quantum physics theory and its implication, but also has an emotional connection and genuinely feel convinced by
some kind of firm conviction out
then-
of reasoning, out of research, firm conviction, no independent existence.
Intrinsic
extinct.
intrinsic existence.
Oh, that one. I don't know that word.
So, and you can compare that person's attitude to others in ethically challenging situations versus someone who has this more absolutist view and grasp onto things based on that absolutist views. Maybe one could
See a difference.
see, check.
I think naturally, you see, those people, more experienced people, who really passing through a lot of sort of difficult sort of life or
Life
experiences.
experience, huh?
Then someone who never faced such difficulties, then when you see passing through some difficult situation, the person who lot of experience, their mind, their response to that sort of tragedy, much more calm.
Yeah.
The other one, too much sort of excitement, too much of the frustration of these things. So similarly, you see, these sort of, because of the wisdom, helping something like regulation
Right,
about
right.
our emotion. So that's the way.
You speak of
So then these scientists,
And then
Master.
celebrate. Then I will celebrate you, scientists.
oh, those scientists as a guru, great guru. 배워서 샤몬 담을 가워야 비자. 이제 참 science guru들이야 샤몬 믹스싱 했어요.
And given that we Tibetans are so fond of hats of all sorts of shapes and kind, we could actually make a special hat for the science gurus.
science guru.
I think Your Holiness has to be a very big hat.
아직 대사업 거야. 샤몬 첨부시 이국사 예들 지게.
이공.
이구 저서 안 되지 마지 샤 있는 전에 배 10분 14호시 야 그것은 이구도 또
So maybe for the Solons was saying maybe for the quantum physicist you can have a huge hat but with lots of holes. Because when you make the presentation, it all looks so wonderful. Then when you look at the implication, it's full of holes.
sorry.
Hat, not hat. Thank
Thank
you very
you.
much. I think we
Yes.
should close on that wonderful note. Thank you. Could I just remind everybody that we begin again at 4 with the question